You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Clarity in the backlog is not a cosmetic concern. It is the foundation of predictable flow and trustworthy delivery. When items are defined precisely and acceptance criteria are verifiable, teams move forward with confidence that they are building the right thing, and that progress can be demonstrated objectively. A clear backlog prevents the waste of rework, reduces friction in handoffs, and strengthens the credibility of demos. Without it, flow is disrupted by debates about intent, quality becomes unreliable, and stakeholders lose trust in whether done really means value delivered. The orientation toward backlog clarity recognizes that ambiguity compounds quickly. A vague story becomes a misunderstood build, which becomes a failed release. By contrast, clarity compounds positively. Precise framing accelerates refinement, testing, and acceptance. Backlog clarity is not about bureaucracy, but about ensuring that every slice of work contributes meaningfully and predictably to outcomes that matter. Problem-first item framing ensures that teams begin with the why and who before debating the how. Instead of starting with a proposed solution, items should describe the affected role, the desired outcome, and why it matters. For example, rather than writing, "Add a button to export reports," a problem-first framing might be, "As a compliance officer, I need to export reports in approved format so I can meet audit requirements." This keeps the discussion anchored in purpose and user benefit, rather than prematurely narrowing implementation choices. Problem-first framing also prevents solution bias, which can stifle creativity and overlook better alternatives. Over time, this practice shifts team culture from building features to solving problems. It ensures that backlog items serve as invitations to discover the best approach, not as mandates to implement an assumed fix. This orientation keeps the backlog aligned with outcomes and stakeholder needs. User story grammar builds on problem-first framing by capturing role, need, and purpose in plain, human-centered language. The familiar format, "as a role, I want, need so that purpose," keeps focus on who benefits and why. For example, as a user with limited vision, I want the interface to support screen readers so that I can access features independently. This structure resists drift into purely technical descriptions that lose sight of context. It also promotes empathy, as teams repeatedly hear the backlog described in terms of real people and their needs. While grammar should not become rigid, it provides a baseline discipline that reinforces clarity. Over time, user story grammar creates shared language across roles, reducing miscommunication between product, engineering, and stakeholders. It also supports testing and acceptance, as criteria flow naturally from well-expressed needs. Grammar transforms stories from vague placeholders into meaningful, user-centered commitments. Acceptance criteria translate needs into verifiable conditions of satisfaction. They serve as the anchor for scope, test design, and done decisions. Well-written criteria describe observable outcomes, what behavior or evidence must exist for the story to be accepted. For example, report exports must complete within 30 seconds and be in PDF format readable by compliance tools gives a shared definition of success. This reduces ambiguity during development and prevents disputes during review. Acceptance criteria also provide the foundation for automated testing, making quality measurable and repeatable. Over time, this practice builds trust. Stakeholders see that delivery is tied to agreed evidence, not subjective impressions. It also streamlines flow, as less time is wasted in rework or debate about intent. Acceptance criteria are not about restricting creativity, but about ensuring clarity of outcome, so innovation can flourish within trusted boundaries. Ready versus not ready signals provide discipline for when items are pulled into active work. A story should only move forward when it meets a minimum set of information: clear context, identified risks, visible dependencies, and agreed acceptance criteria. If these signals are missing, the item remains in refinement rather than entering the sprint or iteration. This prevents half-baked stories from clogging delivery flow and ensures teams work responsibly. For example, an item lacking acceptance criteria should not be pulled simply because capacity exists. Doing so invites confusion and rework. Ready signals provide a visible gate. They communicate both quality standards and timing expectations. Over time, this practice reduces variance in cycle times and improves predictability. Teams learn that it is better to clarify upfront than to stumble mid-build. Ready signals keep work flowing smoothly, balancing responsiveness with discipline, and protecting quality across increments. The Invest heuristic offers a quick way to check backlog item quality. Items should be independent, negotiable, valuable, estimable, small, and testable. Independence ensures items can be worked without excessive coupling. Negotiability means the story invites discussion, not dictates a solution. Value guarantees user or organizational benefit. Estimability provides enough detail to forecast effort. Smallness ensures the item can be completed within one increment. Testability ties directly to acceptance evidence. For example, a story that is too large or too vague will fail several invest checks, signaling the need for refinement. The acronym is not a rigid gate, but a diagnostic. It highlights weaknesses quickly. Over time, invest discipline increases backlog health, preventing accumulation of vague, oversized, or non-testable items. It builds predictability, as stories consistently flow through refinement into delivery with clarity. Invest creates a culture of quality at the item level, compounding into system-level reliability. Splitting strategies allow teams to decompose large items into thin end-to-end slices. Instead of delivering a massive feature in one risky block, stories can be split by user scenario, data range, or interface path. For example, an export reports epic could be split into export one report type, then add multiple formats, and later support batch exports. Each slice delivers observable value or learning, reducing risk. Splitting strategies ensure that progress is visible sooner and feedback arrives earlier. They also prevent hidden overcommitment, as each slice represents a bounded investment. Over time, teams become adept at identifying natural seams for decomposition. This skill accelerates flow, turning daunting epics into manageable slices that validate assumptions incrementally. Splitting is not about diluting value but sequencing it, ensuring that each increment both advances outcomes and provides insight into what matters most. Non-functional acceptance criteria ensure that increments are not only functional but also trustworthy in real-world conditions. These criteria include performance, security, accessibility, and operability expectations. For example, a login feature is not complete if it only authenticates. It must do so within performance thresholds, enforce encryption, and meet accessibility standards. Embedding these conditions at the story level ensures that increments are releasable, not just coded. Non-functional acceptance prevents technical debt and trust erosion caused by neglecting qualities users assume are built in. Over time, integrating non-functionals into backlog clarity raises baseline quality across the system. It also strengthens trust with stakeholders and regulators, who see that increments are safe and sustainable. This practice reinforces the principle that value includes reliability and fairness, not just features. Non-functional acceptance criteria transform stories into holistic commitments to both functionality and integrity. Examples as specifications use concrete cases to clarify intent and reduce ambiguity. Instead of abstract statements, teams capture edge cases and scenarios that illustrate desired behavior. For example, acceptance might include: export must succeed when data set has 10 rows, 1,000 rows, and 100,000 rows. These examples become living specifications. They guide development and testing with shared precision. They also serve as communication bridges between roles, as concrete cases are easier to understand across disciplines. Over time, examples reduce rework, as misunderstandings are discovered early. They also support automation as test cases flow directly from specifications. This approach aligns with behavior-driven development, where examples describe intent in human-readable form. Examples as specifications transform stories from ambiguous instructions into shared contracts of behavior. They strengthen trust, ensuring that when increments are delivered, everyone sees the same evidence of value achieved. Capturing data and telemetry requirements directly in the backlog ensures measurement at release. Too often, features are shipped without the ability to validate outcomes or monitor behavior. By including telemetry as part of the story, teams ensure that learning and rollback are possible from day one. For example, a story might specify, capture time to export metric for each session and log failures. This allows product teams to validate whether increments met goals and operations teams to detect issues early. Embedding telemetry also enables safe rollback, as evidence of degradation is visible quickly. Over time, this practice turns backlog items into sources of ongoing learning, not just delivery events. It ensures that validation is embedded, not bolted on later. Data requirements transform stories from temporary outputs into long-term evidence generators, sustaining trust that delivered increments can be measured and improved responsibly. Dependency notes make upstream and downstream connections explicit. Many stories touch shared systems or interfaces, and ignoring these connections creates late-stage surprises. By recording dependencies, such as contract expectations with other APIs or required data availability, teams can plan sequencing and integration tests proactively. For example, a reporting story may note that it requires upstream data pipeline stability. Dependency notes prevent optimism bias, where teams assume availability until reality disrupts plans. They also support transparency, as stakeholders can see risks earlier. Over time, this practice reduces rework caused by hidden dependencies. It also strengthens collaboration, as teams coordinate proactively across boundaries. Dependency notes transform backlog clarity from isolated slices into system-aware commitments, ensuring that increments fit reliably into broader ecosystems without introducing hidden friction. Risk notes surface assumptions and potential hazards associated with backlog items. Every story carries exposure, whether technical, operational, or user-facing. Recording these risks directly with the item ensures they shape design, sequencing, and testing. For example, a story may note, assumption: API response times remain under 500 milliseconds. Risk: vendor throttling may cause delays. Capturing this information prevents surprises and helps teams design mitigations early. Risk notes also support prioritization. Higher risk items may be sequenced earlier to test assumptions safely. Over time, integrating risks into backlog clarity builds resilience. It ensures that risk management is not a separate checklist but part of everyday product flow. This visibility also strengthens compliance, as evidence of proactive risk handling is captured naturally. Risk notes transform backlog items into transparent contracts. They include not only intent, but also awareness of exposure. Definition of done alignment connects item-level acceptance to team-wide standards. While each story has its own criteria, all stories must also meet broader quality thresholds, such as code review, automated test coverage, and documentation updates. Aligning these ensures consistency. No increment is considered done until both item-specific and systemic standards are satisfied. For example, a login feature may meet acceptance criteria for function, but must also pass security scans defined in the definition of done. This alignment prevents gaps where stories appear finished but undermine system quality. Over time, it reinforces reliability, as every increment builds on a consistent foundation. It also strengthens stakeholder trust, as demos consistently meet both functional and non-functional expectations. Alignment ensures backlog clarity scales, not just at the item level but across the entire product system, embedding discipline into the rhythm of delivery. Traceability links backlog items to decisions, risks, and controls where required. This practice embeds compliance into everyday work rather than layering it on at the end. For example, a story implementing encryption may link to the decision record mandating data protection and the control reference in compliance frameworks. Traceability provides auditors with evidence while reducing burden on teams. It also preserves rationale, so future contributors understand why certain standards were applied. Over time, this practice builds credibility. Stakeholders trust that product increments are not only fast but also accountable. It prevents the false dichotomy between agility and regulation by showing that both can coexist. Traceability transforms backlog items into nodes in a transparent evidence chain. It demonstrates that clarity is not only about building correctly, but also about showing compliance with principles, policies, and obligations. Anti-pattern awareness helps teams recognize backlog practices that undermine clarity. Vague stories like improve performance invite endless debate. Acceptance criteria written as implementation steps, such as add index to database, obscure outcomes, and reduce creativity. Catch-all items that combine multiple goals hide uncertainty and create unpredictable scope. These patterns increase rework, delay acceptance, and frustrate stakeholders. By naming them, teams develop vigilance and self-correct. For example, reframing improve performance as reduce page load time to under 2 seconds for 95% of sessions transforms ambiguity into clarity. Over time, awareness builds maturity. Teams learn to recognize when backlog practices drift toward shortcuts that erode trust. Anti-pattern vigilance ensures that backlog clarity is sustained, not undermined by pressure or habit. It protects the foundation of predictable flow and meaningful demonstrations of value. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Refinement cadence is the heartbeat that keeps the backlog fresh and usable. Rather than trying to perfect every future item, teams schedule short, frequent sessions to clarify only the near-term slice of work. This approach avoids the trap of over-specifying distant items that may never be pulled. For example, a team may refine stories for the next 1 or 2 iterations, ensuring they are ready to pull, while leaving long-tail ideas lightweight until evidence justifies investment. Cadence also prevents spikes of preparation work that drain energy. Small, regular refinements spread the load, reducing surprises when items reach delivery. Over time, this rhythm embeds discipline. The backlog remains continuously healthy, with clear items always available, yet it never bloats with premature detail. Refinement cadence proves that backlog clarity is not a one-time effort, but a sustained practice that matches learning with flow. Collaborative refinement ensures items reflect the perspectives of all roles involved in delivery and risk. Refinement sessions should include product, engineering, design, quality, and compliance partners, each of whom sees issues others may miss. For example, an engineer may highlight technical dependencies, a designer may raise accessibility concerns, and a risk partner may flag compliance implications. Without collaboration, stories risk being written in isolation, only to unravel when unseen constraints surface. Bringing diverse roles into refinement creates shared ownership of backlog clarity. It also builds trust, as everyone sees their expertise respected in shaping items. Over time, collaboration reduces late-stage surprises, improves quality of increments, and accelerates flow. It reinforces that clarity is not just a product manager's job, but a team responsibility. Backlog clarity grows stronger when refined through many eyes and disciplines rather than through one narrow lens. Visualizing acceptance as outcomes prevents checklists from becoming a substitute for value. Instead of writing criteria as fields must be saved or button must appear, outcome-based criteria state what observable behavior or system evidence should exist. For example, user profile changes persist across logins and appear correctly on dashboard describes an outcome, not just a step. This framing keeps attention on user impact and system reliability, ensuring that increments are measured by what they achieve, not merely what was done. Outcome visualization also improves stakeholder demos, as teams can show evidence of success that resonates with users. Over time, this practice strengthens accountability. Increments are judged by meaningful results, not by ticking boxes. It also aligns with testing, as outcomes naturally suggest observable verification. By focusing on outcomes, backlog clarity ties work directly to purpose, ensuring that value remains at the center. Testability checks are a litmus test for clarity. Every acceptance criterion should be answerable by the question, how will we verify this? If a person or system cannot realistically confirm a condition, the criterion is incomplete. For example, the system must be intuitive is vague, while 80% of new users complete onboarding without external help is testable. Testability aligns backlog items with automation opportunities, as clear criteria can be embedded into continuous testing pipelines. It also prevents subjective disputes during reviews, as evidence is observable. Over time, testability checks build predictability. Stories flow smoothly through delivery because acceptance is unambiguous. They also encourage discipline in refinement, as teams catch unclear criteria before they reach build. Testability transforms acceptance from aspiration into measurable fact, anchoring backlog clarity in outcomes that can be trusted and repeated. Data readiness is often overlooked but essential to backlog clarity. Many increments depend on test data, anonymization, and retention rules to validate behavior responsibly. Capturing these requirements at the item level ensures that testing and telemetry are reliable and ethical. For example, a story involving reports may require anonymized sample datasets that reflect edge cases like missing values or extreme ranges. Without planning, teams may discover too late that data is unavailable, blocking testing or skewing results. By embedding readiness, teams align functional and ethical obligations. It also ensures that telemetry for validation is present at release, allowing outcomes to be measured. Over time, this practice reduces friction and accelerates safe rollout. Data readiness signals maturity. Backlog clarity includes not just what will be built, but how it will be tested, validated, and monitored in responsible ways. Error and exception paths deserve explicit attention during refinement. Too many stories are written for the happy path only, ignoring real-world variance. For example, a login story may describe success but omit criteria for incorrect passwords, expired accounts, or system errors. When exceptions are not captured, increments fail under stress, eroding trust. By explicitly defining error handling, teams ensure robustness and predictability. This clarity also aids testing, as error conditions become part of acceptance. Exception coverage prevents false confidence, where features appear complete but fail in production. Over time, systematic inclusion of error paths raises resilience and reduces support load. It also shifts mindset. Backlog items are not just about demonstrating success, but about preparing for failure gracefully. Clarity in error handling strengthens trust, proving that increments are ready for the full spectrum of user and system behavior. Contract and API criteria anchor backlog items in safe interface evolution. Many products depend on APIs and integrations, where changes ripple across consumers. Backlog clarity requires specifying versioning rules, backward compatibility, and contract tests as part of acceptance. For example, an API story might include existing consumers continue to receive valid responses, new fields documented in V2 spec. This prevents accidental breakage and ensures external trust. Criteria also guide testing, as contract validation becomes part of release readiness. Over time, embedding interface standards reduces integration failures and strengthens cross-team collaboration. It also builds resilience as systems evolve with predictable contracts rather than ad hoc changes. Backlog clarity at the API level signals professionalism. Increments are not only functional internally, but also safe and transparent to the broader ecosystem. Contract clarity is essential for sustainable system-level trust. Operability criteria expand backlog clarity into supportability from day one. Stories should specify logging, alerts, dashboards, and rollback instructions, not just user-facing functionality. For example, a deployment feature might include logs must capture failure reasons, alert triggers if failure rate exceeds 5%, rollback documented. Operability ensures increments are not just built, but maintainable and observable in production. Without this clarity, features may ship but become burdens for support teams. Embedding operability criteria aligns with definition of done, reinforcing that increments are only complete when they can be supported responsibly. Over time, this practice builds resilience, reducing outages and accelerating incident response. It also fosters collaboration between development and operations, breaking down silos. Backlog clarity that includes operability proves that value delivery considers the full lifecycle, not just coding. It ensures trust is maintained long after release. Story maps and threads preserve coherence across multiple slices pursuing the same outcome. Large features are often decomposed into smaller stories, and without mapping, the purpose can be lost. Story maps visually link items to higher-level goals, while threads connect discussions and decisions. For example, a retention theme may include slices for onboarding, feedback prompts, and error recovery, all tied together in a map. This clarity ensures that increments add up to meaningful outcomes rather than scattered tasks. It also supports prioritization. Teams can see dependencies and choose slices that maximize early value. Over time, mapping strengthens strategic alignment, keeping backlog flow tethered to vision. It also reduces stakeholder confusion, as they can trace how multiple slices contribute to shared goals. Story maps and threads transform a queue of items into a narrative, ensuring coherence even as work is sliced thin. Remote refinement practices adapt backlog clarity to distributed environments. Pre-reads ensure participants arrive prepared. Asynchronous comments allow thoughtful input, and concise live sessions resolve ambiguities. For example, a team may circulate draft stories with acceptance criteria ahead of a call, then use synchronous time to clarify disagreements rather than rehashing context. Recorded sessions and shared artifacts preserve clarity for absent members. This reduces meeting sprawl while improving inclusivity across time zones. Remote practices also create durable records, improving accountability and reducing repeat confusion. Over time, distributed refinement strengthens backlog health by ensuring participation is not limited by location. It embeds fairness and clarity as cultural values. Remote-friendly refinement proves that backlog quality does not depend on co-location. Clarity flows from preparation, shared artifacts, and structured dialogue. It makes product flow scalable and inclusive across geographies. Ready-to-pull signals provide auditability and freshness checks. When an item is refined and ready, it is marked with owner and date, making it visible that it passed readiness criteria. This prevents stale stories from lingering unnoticed and ensures accountability for backlog health. For example, a story marked ready 6 months ago can be flagged for review before pulling, as context may have shifted. This practice aligns with compliance needs, as audit trails show how and when items were prepared. Over time, readiness signals reduce surprises in delivery, as teams only pull stories that meet clear current standards. They also preserve backlog hygiene, stories that age are revisited or retired. Ready-to-pull records transform backlog clarity into visible discipline, ensuring both accountability and adaptability. They prove that clarity is a living quality, not a one-time checkbox. Post-demo verification closes the loop by comparing observed behavior against acceptance criteria. After a demo, stakeholders decide whether acceptance was met, whether small follow-ups are needed, or whether new backlog items should capture additional scope. This discipline prevents ambiguous done declarations. For example, if a story passes most criteria but fails one edge case, the decision might be to accept with follow-up or defer. Post-demo verification keeps flow clean. Increments are either accepted or explicitly linked to next steps, preventing hidden debt. Over time, this practice raises trust. as stakeholders see that quality is judged transparently against agreed standards. It also sharpens learning. Feedback from demos flows directly into backlog refinement. Post-demo discipline proves that backlog clarity extends through delivery, ensuring alignment between intent, evidence, and acceptance decisions. Learning capture prevents repeated confusion by updating glossary terms, examples, and patterns whenever ambiguity is resolved. For example, if a story exposed misunderstandings about what onboarding means, the glossary is updated with clarified definitions and examples. This prevents the same debate and future refinements. Learning capture turns backlog resolution into organizational memory, compounding clarity over time. It also improves onboarding for new team members who inherit clean definitions rather than legacy confusion. Over time, this practice reduces cognitive load, as teams no longer rehash old misunderstandings. It transforms backlog refinement from a reactive cleanup process into a proactive learning system. Learning capture ensures that every resolved ambiguity strengthens future clarity, embedding continuous improvement into product flow. It proves that backlog clarity is cumulative, not just episodic. Success evidence confirms whether backlog clarity practices deliver impact. Metrics include fewer rework loops, tighter cycle time distributions, and higher first-pass acceptance rates. For example, if items are consistently accepted without repeated revisions, clarity is validated. If cycle time variance shrinks, it shows that stories are predictably flowing. These outcomes prove backlog clarity is not theoretical, but practical. Over time, success evidence builds stakeholder trust. They see that clear items deliver reliable increments. It also motivates teams as they experience smoother flow and fewer frustrations. Success is not just better documentation, but better outcomes. Value shipped sooner, with fewer reversals. By measuring impact, organizations sustain investment in backlog discipline. Evidence proves that clarity is not overhead, but leverage, multiplying the effectiveness of every slice delivered. Backlog clarity synthesis emphasizes the centrality of precise framing, verifiable acceptance, and collaborative refinement. Items are defined with problem-first statements and user grammar, acceptance criteria, anchor scope and quality, and practices like splitting, non-functional embedding, and telemetry planning ensure readiness. Refinement cadence and collaborative sessions keep the backlog fresh, while testability, error paths, and operability criteria ensure robustness. Story maps preserve coherence, remote practices maintain inclusivity, and ready-to-pull signals create accountability. Post-demo verification and learning capture close the loop, while success evidence proves impact in smoother flow and higher acceptance. Together, these practices transform backlog management from a task list into a disciplined system for delivering thin slices that reliably meet intent. Backlog clarity turns uncertainty into precision, ensuring that teams ship increments that are both trustworthy and valuable the first time. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.